As we look at topic 6.1, we're dealing with function and a section called composition, where something is composed of something else. So the symbolism of this is that we say F, this little circle indicates composed of G. So F composed of G, and we're taking the value of 1. Then later we're going to do G composed of F. Again, the value will be 1. So what does this mean? Well, as we look at example 9, and this is in your textbook for the end of section 6.1, example 9, and this is the information they give on the top, and they're giving you now the actual function of f, which is x squared plus 1. And this is a semicolon to separate them. And then they're giving you the function of g, which is x minus 3. So how does this take place? Well, we take our 1, and since this is a function of g, we go to the g function first, and where there's an x, we put a 1. So I've just shown that here, where our x will be 1, and where the x is in the statement, we put a 1. So 1 minus 3 is negative 2. So we now have our g function that we're now going to bring into our f function. So what do we do here? Well, this is going to be f, where f is, the x value now is a negative 2. So where the x is, we put in negative 2 squared plus 1. Now, negative 2 squared is a positive 4. 4 plus 1 is 5. So the answer to 9a, actually, which is this example, where it's the function of f composed with g, where it's 1, is 5. Now to keep that there, we want to then do the next part of this, where it's g composed of f, and again our value is 1. So what we're going to do now is put the 1 in our f function first. So this will be f of 1 is equal to x squared plus 1. So now x is 1. 1 squared is 1. 1 plus 1 is 2. So we have taken our f function first, put in the 1, and we end up with a 2. We now take this 2 and put it in our g function. So it's g of 2 now, where x minus 3. So our x is going to be 2 minus 3. This equals a negative 1. Now in part C of example 9, we're using the same protocol. That is, we want composition of G here, where our value will be x. And for the second part, G composed with F, where our value is x. So again, how do we do that? Well, in this case, we're going to take the value for g, this function, and that will be our x. So this is our x that we're now going to bring over here. So in a sense, it would be f, our x is x minus 3 now, bringing it right from there, and that is x squared plus 1. So what do? Well, we take this and replace it the x. So it will be x minus 3, the quantity squared. So again, this is our g value, and we want to find the x. So this is x that we're going to replace in our f function. So our x here replaces this. We substitute it in our expression, and we get that. And it's plus 1, of course. Now we square a binomial. This is x squared minus 6x plus 9 plus 1. So this then becomes x squared minus 6x plus 10. So when we compose f with g, or f of g, where we're just using its x value, which is what this is, taking this, substituting it into our f function, we get this as an answer. Now how about if we do it the other way? G composed of f. Well, what is our x value there? Well, our x value there is this. So we can set it up. G x squared plus 1 equals x minus 3. So we say our x value is replaced by this. So in parentheses, x squared plus 1, that's our x value, now minus 3. So this then becomes x squared. You just get rid of the parentheses. And then 1 minus 3 is negative 2. So when g is composed of f, where we're solving for x, we take our f function, which is right there, substitute it for the x, and this is what we get. Now an interesting thing happens. You may recall that before, when we put a 1 for x, x was 1. This was also 1. When we did it this way, using this function, we got that this was equal to, when x was 1 here, a 5. So we can see if in fact we actually get a 5 out of this, and let's try it. So we're going to take our x squared, which we said was 1, minus 6 times 1, again we're using this 1, plus 10. Well, 1 squared is 1. A negative 6 times 1 is a negative 6 plus 10. So 1 plus 10 is 11. 11 minus 6 is 5. So it checks. Now how about this one? When we did this one earlier, we got this as being a negative 1. So if we put a 1 in there, which is our g composed with f, where we used a 1, x now is 1, so 1 squared minus 2. Well, 1 squared is 1. 1 minus 2 is negative 1. And this one checks. So often this is the protocol you will follow, where they give you a number value here initially, and then they want it in a sense generally, where you just substitute the x value, as we've done here. Then you can use that new composition to just take that original value, put it in what you got, and you get the answers. So this may be a good one that you'd want to look at again and try it on your own. Again, this is example 9 at the end of section 6.1.